Good afternoon. It is November 15th, 2012. This is Jason Horak talking about the 1987 Dodge Daytona electric vehicle. Well, as you can see, we're still in the garage. And the car's been sitting here for now over a month since the motor came to its untimely demise and has now been shipped off to Illinois. Latest word is that it has arrived at Warfield and they're working on it. I believe the exact word she used was that the motor was being evaluated. So I'm really not sure how long that's going to take, but it's in their capable hands, so not much I can do. So in the meantime, what I've been doing is working on my batteries. And I don't know if I mentioned this in an earlier video or not, but due to the way that I had the 53 of the 60 batteries installed in the car originally, and then added the 7 in, did a kind of a bottom balancing routine on all 60, then I had to take out those 7 and put I ran the car just with 53 for a while. Well, this caused a kind of an imbalance between the rest of the pack and those 7. And so what I've been doing is I want to re-bottom balance the pack, this time taking it down even further than before. The first time I had gone down to 3 volts per cell, and they were balanced, and they seem to be staying in balance pretty well, but I want to take them down a little further, maybe about down to 2.8 volts per cell. So what I've got set up here is all the batteries are, of course, still wired up in series, and so the main battery pack is showing about 180, let's take a look here, 183.7 for all 60. And so I've gotten it down pretty well, but we've still got a little bit more to go. So what I'm going to do is I've got the good old Metropolitan Industries 12 volt battery. This is the same type of battery that powered the first electric car, and I'm using that to power my little Riva Electrics Power Lab 8. And if I can do this one-handed while holding the camera, it will be a miracle. Alright, look at that. Ta-da! Okay. So I've got this hooked up to one of my 7 batteries. When I had rebuilt this new battery box in the front, I put the 7 new ones up here so that it's this one and then those 6. Those are the ones that are technically out of balance with the rest of the pack. So what we're doing is the old Riva Electrics power source battery, and I've got a profile set up for the A123s. I use the A123 configuration, and then I created one called CALB 180s that are LiFePO 4 cells. So anyway, we'll take a look at those. We're not using parallel packs. Charge rate of 40, discharge rate of 40, and instead of a charge-discharge, I'm going to set it to monitor instead. And using the Banana Jacks, yes. Checks the pack, confirm that it is A123. Of course, they're not really A123 batteries, but that's the only one that this Power Lab supports. So anyway, we're going to go down here and take a look at what it's showing for voltage. So right now, we're showing 3.05 volts. Again, on one of these cells that was kind of out of balance with the rest of the pack. So we're going to take these leads off, leaving the Power Lab 8 running, and just hook them up to one of the other batteries in the pack that were part of the original 53. And so here we're showing 3.10. So we're reasonably close, but off by a little bit. This kind of fluctuates to 3.09, so it's probably right on the verge there. But yeah, so all the rest of the batteries in the pack, and again, we'll grab just another random one here. Let's go with this one here. 3.09. So very consistent amongst all the batteries that I had bottom balanced together and left as a pack. So that's reassuring. that this whole process is not for naught. But what I'm going to do is drain the entire pack down all at once using my heater element. And so we're going to put these leads back on just one of these here at the end, 3.05 on the Riva Electrics. And then what we're going to do is turn on the heater. And so what we're going to do there is just run the two ceramic elements that are hooked up to the heater, as well as the, no doubt, relatively loud blower. As you can see, the pack voltage dropped pretty significantly right away, down to 179, and now it's doing 178.9, 178.8. So we're definitely on the steep part of the curve. And what's interesting is to watch these cells. So again, we're looking at one of the 7 batteries that was added later, and that's currently showing 2.95 volts. I'm not sure if the camera's actually making that out or not, but 295. And so what I'm going to do, because those batteries are lower than the rest of them, I'm going to use those as kind of my bottom and just watch this as it drops until I'm showing 2.8 volts stable on the Power Lab. So when I've got 2.8 volts on these 7 batteries, I will call that empty for those batteries, and then I'm going to go through and bleed off the rest of the 53 batteries in the back down to the 2.8 volts as well. And so everybody should be all matched up at 2.8, and we'll be styling. So that's the basic plan to get it there, and I will come back with further video once we get down to the point where we're actually lowering those other 53 batteries. And you know, it's going to be a long process, but I figured it was worth capturing on video just to kind of get the whole process down of, you know, how I do this. And maybe it'll be beneficial to somebody, I'm not sure. So, kind of like watching paint dry, as Jack Rickard says, but perhaps worthwhile. So, anyway, I'll be back. Okay, just for reference, as you can see, we're at 159.8 volts for the whole pack and dropping. And I just wanted to show you that we're pulling 18 amps. That's a combination of the heater and the blower, which is of course running off the DC to DC converter. So 159.2, again, dropping pretty precipitously, as Jack says. And now let's go ahead and check where we're at with on the Power Lab. Now I have identified the lowest cell as being this one out of the 7, and I got that hooked up to the Power Lab. So we're now showing 252 or 2.52 volts rather. Now my plan is to stop it at 250 and then let the car settle, or let the battery settle, and see where we're at when they're not under load. I'm guessing they'll bounce up probably about to the 2.8 mark. Oh, there we go, 2.49. So we're going to go ahead and turn off the car. And so our voltage here is 157.4. And we turn things off, and of course it immediately bounces back. 161, 162, and so we're coming back up. 163, starting to kind of slow down here a little bit. 164, okay. So now let's have a look at what the Power Lab is showing. And so we're at, well, I guess it came up to 2.64. So that's, we'll see how high that actually comes up according to this gauge. And then what I'm going to do is check one of the other non-7 cells. again, just kind of at random, and that's a 2.84. So my goal at this point will be to try to get all of the cells to 2.80 using the Power Lab by either discharging them a little bit or charging them a little bit to get them there. But at this point I'm going to let them rest for just a little while, maybe about 15 minutes or so, and we'll see where we're at then. Yeah, 2.66 on that one, and back on our original test subject, where we're at is at 2.75, and again probably still climbing a little bit after being off the load. So anyway, I'm going to give them a little rest, and then we will commence with battery bottom balancing. Woohoo! Be back in a bit. Okay, it's a few hours later, and we're at 172.9 volts up to 173 volts for the entire pack. That works out to about 2.88 volts per battery. So that's a pretty good place to start for this whole bottom balancing thing, and it's about as close as I can get it with just running the heater and the blower fan and so forth. So just a quick review, we've got a 12 volt Metropolitan Industries AGM battery that is powering the Power Lab 8, the Revolectrix Power Lab 8, and that is hooked up to one battery in the pack, which in this case is the just this one on the end. It is one of the original 53 cells that currently is at about 2.9 volts per cell. It kind of fluctuates between 2.9 and 2.88, so it's hard to tell just based on the meter here. So anyway, so that's going to be our little test subject here for the first one. And what I've done is, using the programming software, or rather the software for this Revolectrix, I have set up, I'm not sure how well the camera's going to make this out, but I created a profile using the A123 baseline that I called the A123 Calb 180 bottom balance. And this one is set up so that we can do just a straight discharge to a certain voltage. So the way we do that is we just hit the start button here, and then it gives us some choices: charge only, regen, discharge only, monitor, etc. So we want to use regen discharge only, and then we're going to confirm that it is an A123 type of cell chemistry, even though of course it's a Calb, not an A123, but yeah, you know how these things work. Alright, so this is showing that we don't want to save our other graph. And I'm going to pull up the graph on the page here. And so it started out at about 2.9 volts, and then it's lowering it down to the 2.8, and so right now we're showing on here 2.8 volts. So it went from a pretty quick drop, and now the current is dropping pretty sharply, of course. 12 amps and dropping, and so this really shouldn't take too long. It says we're pulling out 200 milliamps from the battery, and we're just going to let this go until it stops of its own accord, which should be right at 2.80 volts, and we'll call that good for each battery in the pack. So again, because I bled them down so close already, this really shouldn't take too long for each battery. Since I have to do 60 of them, I'm trying to minimize how much time it takes for each one, and as much as possible. So anyway, it's just kind of chugging along, doing its thing, and I guess I'll probably let it just go. So we're down to 6 amps and still dropping. 5.8. Again, I'm sure the camera isn't making this out very well. It's not a high-res camera or anything, but so it's holding right at 2.800 volts, and it's still pulling it out. Again, this particular unit can do a total of 40 amps, and that's what I got it set to, is to pull out 40 amps at a time, but then it hits constant voltage. Once it hits that, it lowers the voltage down to that point, 2.8 in this case, and then it holds it there while continuing to draw out power, and it just keeps lowering how many amps it's sucking out of the battery down to about a half an amp is what I've got it set to, 500 milliamps. So it'll just keep sucking it down until it gets to that point. And the reason why you have to do that is because as soon as you stop applying a load to the cell, it'll bounce back up some. So the idea is you kind of taper off the current until it's down to just about nothing. So this is about the most accurate way to set the capacity of the battery that I can come up with, and it seems to work pretty well. So we're down to about 3.5 amps now, 3.4. We've pulled a total of 430 milliamps out of the battery. So obviously we're not dealing with a lot of power here, but since I'm going through all this effort to get all the batteries balanced, I want to make sure they're as close as absolutely possible to exactly the same for every cell. And they're pretty close already. I mean, at this point, just by kind of adding a little and taking a little away from each battery, I've got them down to about 2.9 volts per cell across the board, and that's pretty darn close, but I want to get it a little more exact since I have the tool to do the job, and we'll go from there. It's kind of interesting to note that the amp, or the voltmeter that I have, the little multimeter, shows a completely different voltage than what we see on the Revolectrics. And just for fun, so right now we're at 2.80 according to the Revolectrics device. Oh, and it just finished. Okay. We'll just call that test. And yeah, so it is done. And so it pulled out a total of 486 milliamps from this particular cell. And we can see that the voltage is kind of creeping back up now that the load has stopped. So we're back up to 2.808. And depending on the temperature and stuff, I'm sure that'll fluctuate. It is currently 46.1 degrees here in the garage, and I do have a little propane heater burning to keep me warm, as well as a electric space heater to move a little bit of air around. It's quite cold out. It's probably pushing 25 or something outside, so we do what we can. So anyway, that's kind of the process, and so now that it's finished, it says it took 4 minutes and 19 seconds. So we're just going to take this battery and so it crept back up to, where are we at now? Does it say 2.84 volts? So that's a little higher than 2.80, but at this point I think it's close enough for government work. So we're just going to move the terminals to the next cell in the pack. Make sure they're on there nice and tight. And so this one's at 2.94 when we start the process. And again, we can do it right from this. Discharge stopped. Goes right through. Discharge only. Yes. Yes. And we're running. So again, it does exactly the same thing as starting it on the laptop. And in fact, the laptop will show us what's going on here and graph it and everything also. So definitely a very handy little device, and very useful for doing this kind of thing. I'm sure a big resistor and just bleeding it off to heat would be just as well. Incidentally, these milliamps that we're pulling out of these CALD cells are going back into serving to regen into this AGM battery, so it's not being wasted necessarily. But you know, again, we're dealing with very small amounts of power, so it doesn't really matter. But hey, you know, I guess anything helps. Oh yes, what I wanted to show you was just the discrepancy with the multimeter. I'm sure it has to do with like calibration of these things and you know how they measure voltage and stuff. But so right now the Riva Electrics is showing a 2.84 volts on this battery, and we'll turn this in here. Whereas this thing shows me a 2.779. So you know it's pretty close, but you know 2.78 is kind of where it's stabilized. So I just find that interesting that it's a little bit off. So if I was using just this meter to do my calibration, it wouldn't necessarily be that accurate. I guess I could use this meter for all of them, and then they'd all be at agreeing that this meter says they're 2.8. But anyway, just you know, I guess pick a measurement tool and choose that as your standard and go from there. So anyway, as you can see, this is pretty much a watching paint dry situation. You know, we're on the second battery now, and it's dropped down to about 9.8 amps that it's pulling, and it'll keep on going right on down to, I guess it's about 2.5 where it seems to terminate. So anyway, that's the story for tonight. I'm going to keep going and through all 60 of these batteries, and the ones that are in the mid battery box are going to be a pain in the neck to get to, but I should be able to snake these cables down in there and make it happen. So also, as you notice, we don't need the laptop. You can use it for graphing and so forth, but really it's just another way of initiating the process. So now what I'm going to do is, once I'm done with all of this bottom balancing, I'm going to go through and charge again, but this time I'm going to put the Riva Electrics box or unit on one of the cells, probably one of the 7 cells that was out of balance, as I charge the entire pack at once. And I'm just going to use that as a monitor to get an idea of what's going on, and maybe I can create a nice little graph with the program or something. I don't think those batteries were damaged in my crazy efforts, but you never know. So I'll just kind of watch them, and then, you know, whenever something hits too high, that's when I'll be stopping the charge. But it'll be a very manual process at that point, and we'll make sure I don't blow anything up. So anyway, that's it for tonight. I'll catch up with y'all later. Take care and have a good one.